Ladies and gentlemen, I would like to introduce the first participant of the Space Conference second edition, Mr. Matt Hill, CEO of Hypersonix Launch Systems. It's an Australia's leading aerospace manufacturer of hypersonic aircraft and scramjet propulsion technology. Mr. Matt, the floor is yours.
Very helpful. Hello, everyone. It's good to be here today. I've just come up from Kelsey. It's my second time in Poland, and I got to say, I love your country. It's a great place to be. I'm the CEO of Hypersonix Launch Systems, and today I'm going to give pretty much a breakdown of the company, where we're at, and then I understand there's going to be a panel after the presentation, so I really encourage people to ask questions, the more interest we show in each other's companies, the more we can learn, I think. So we're a company that was started in 2019. We've got about 45 staff now, not 42. And we're in just south of the capital of one of our northern states, which is Queensland. We're in Brisbane. And we've got a factory that's actually an ex-prime factory for one of the US primes. So we've been very fortunate with that, and we're really scaling now into a business that has only been around for 6 years. But when I go through some of the history of the co-founders of the business, you'll understand why, even though it's only been around for 6 years, it's actually like a 35-year endeavor or a 35-year project from our co-founder, Dr. Michael Smart. But we're in Brisbane, and we have quite a large facility. We're currently building 2 of our first vehicles, and it's actually taking up most of the space, which surprises me. So it's actually a big facility, and we're very proud of it. So just talking about hypersonic propulsion and air-breathing hypersonic propulsion, our business specializes in scramjets. So we do require a boost to about 50 kilometers up, then we release and we fly. But in the last 10 years, scramjet propulsion has really moved from being something that was a bit of science fiction to something that's practical and is achievable. And the reason why that's happened from our perspective, and I think it's important to everyone, is several things have happened and converged, and it's just like with any new technology, there's been 3 or 4 things that have intersected at the same time, which has enabled this to become feasible. The first one is the cost of boosters and the cost of rockets has gone down significantly. The cost of using a range and the choice of ranges has increased significantly. And there's only going to be more competition in the booster and the rocket space, which is good for us because it's one of the essentials of what we do. So that's happened. The second thing that's happened is the advent of 3D printing and the scalability of 3D printing and the reliability of 3D printing, particularly in Inconel and various types of metals. And the third thing is CMCs and the progression in how we can mold and create different shapes in ceramics, matrix, composites. So that's really, really important for our business because historically it was either just cost prohibitive, it just cost too much money and it just wouldn't have been feasible, or you simply couldn't get the shapes that you were looking for with the qualities that you needed. So our business, I'll just go through the people. I'm the CEO, and my background is I've scaled quite a lot of businesses. I've had quite a few exits. It's my first space business, but it's not the first time I've thought about the space business. I was very, very pleased to get the opportunity to come involved in this business. And my background is I get involved in businesses, I help capitalize them, and I scale them and usually bring them to exit. So very excited about that. But the really exciting person is Michael Smart, Dr. Michael Smart. He's the world's leading hydrogen scramjet expert. He was the professor of hypersonic propulsion from Queensland University, which internationally is probably the leading university for hypersonic propulsion, definitely the leading university for hypersonic scramjet propulsion. and he was the head of the Center of Hypersonics at that university. That's really important for a number of reasons. The first reason is he's really good at building scramjets, and he knows a lot about scramjets. The other reason is he's been a great magnet for us to attract talent and to be able to keep talent into the business, which is, you know, when you're scaling a business and you're working with limited funds and you've got to, you know, you're revolving from, you know, moments of abundance to a moments of scarcity, and you need to go through that. When you've got a personality like Michael involved, it keeps the team together because they know that they're working with somebody who's a one of a kind, and he really is a one of a kind. He also worked at NASA for 10 years, and he's been involved in multiple hypersonic programs, also in Europe, in Andoya as well, in Norway. And our chairman, who's also a very interesting guy, he was the former Australian ambassador to the United States, just the previous ambassador, Alpha Synodinos, and he's my boss, and he's a great boss. And he's really helped us in the last 18 months to help scale the business as well. We've got a lot more connectivity in the US for his contacts, and I'll go through the contracts we've got in the US and how he's helped us with that as well. But getting back to the really important people, our staff, we've got 45 world-class staff. I'd say 85% of them are various types of engineers, and I'd say 85% of that 85% are from University of Queensland. We tend to attract and hire interns. I think we've got almost a one-to-one ratio. If somebody comes in our business and they're an intern, more than likely they're going to be a graduate and they'll get a job. Because what we're doing hasn't really been done before in the way that we're doing it. So sometimes it's better to train a young person to do it from scratch than to untrain somebody who's got their own fixed ideas. But it's also important to have people who have got prime experience. It's really important to have people who have done different things in a different industry and perhaps can apply it to this industry. But we do focus on the young talent because they get very much behind the project, and we've been very lucky in that sense. But we've got specialist scramjet design, aeroshell, flight modeling software, guidance, navigation systems, every type of engineer you can imagine, we've got them on board. We've got great partners who help us 3D print. At the moment, we still don't have our own 3D printer. We don't need to, but we have really good partnerships with 3D printers, mostly in Australia, but also in Europe. So, and that's something that we're looking at as a company as well, is where can we get more access to reliable 3D printing for our aeroshell. Hypersonic flight experience, we've got 4 members of the team who have been involved in programs, including the X-43, High Shot and High Fire. So that really helps because when you've been involved in programs that have worked and not worked, you know, you learn from that. You learn as much from your failures as you do from your successes, and a lot of people would say you learn more from your failures. But we've got a good mix of people who have been involved in successful programs as well as unsuccessful programs, so it's really important. We're also developing our own digital twinning software, and we've been able to get access to some very significant software from the University of Queensland, which has really helped us to develop what we can do in the future, and I'll go through that later in the slide deck as well. But we're as much a software company and a digital twinning company as we are a hardware scramjet propulsion company, and we need both because they both feed the cycle of development. So this is just a bit of a timeline on the history of Australian hypersonics. A lot of people wouldn't associate Australia with hypersonics, and even when I got involved in this business, it wasn't something that I necessarily knew either. I knew that University of Queensland was quite specialised with scramjets, but I didn't know the level of expertise that had come out of our country. It's something that we're proud of, but the University of Queensland has a T4 shock tunnel, which our company, or Michael, has done over 6,000 shock tunnel tests. It's a very unique piece of equipment, and it's really helped us validate on ground all of the mechanics of our scramjet. And you know, in 2002, Michael was involved in the High Shot program, and So that's one of the programs he's been involved in. 2012, he did further ground tests, testing CMC panels, and that's why I come back to CMCs are a really important part of being able to fly at hypersonic speeds, because otherwise everything melts. In 2015, the first hydrogen-fueled 3D scramjet section under the Hi-Fi program was produced. That was with Michael Smart, so that was a really important validation for his hypothesis that, you know, hydrogen was the best fuel for scramjets. And I'll go through a bit more into that in a second, but on the back of that, he started to develop the Hypersonix Spartan scramjet in 2019 and incorporated the company. And then in 2021, we created our first 3D printed fixed geometry scramjet. So our scramjet is fixed geometry. Depending on the materiality or the composition, we can take that scramjet from Mark 5 up to Mark 12. It's been proven in shock tunnels. To get it up to Mark 12, though, it has to be in, you know, CMCs or some very, very seriously expensive materials at this stage, but we are working towards that and working with partners on that. But at the moment, our scramjet is printed in 3D. It's 3D printed in Inconel and some of the components in CMCs. In 2025, it's really exciting. That's our DART vehicle. I've got one on my jacket. In 2025, the DART is going to be flying from Wallops, Virginia with NASA. So it's the last quarter of this year. So anytime between late October and Christmas, we'll be launching. And that's obviously a massive win for us. And we're launching through NASA, but the contract that we got is through the Department of Defense in the US, the department called the Defense Innovation Unit, which I think is one of the most amazing organizations in the world in the way that they incubate, mentor, and allow companies like our company to prove their technology, get commercial contracts, and develop their technology in not just a defense way, but also, you know, geared towards dual use as well, which is really, really important. So our product roadmap, the DART AE, as I said, that's being launched in the last quarter of this year. It's about 4 meters long. It weighs about 370 kilos. It's 3D printed Inconel. It has about a 1 kilo hydrogen tank inside it, and it can use any type of hydrogen, gaseous or cryogenic, but we're using gaseous on the first flight. The payload is 9 kilos. The range is about 1,000 kilometers, and it gets up to Mach 7. We could go faster than Mach 7, but it will melt. So the whole idea is with that vehicle it's like a Formula 1 car. You have 61 laps in the race. You make it so it can last for 62. That's all we've done. Just make it work. So that's what we've done with that vehicle. It was originally going to be our MVP. We never had any ambitions of it becoming a product. We didn't have any. It kind of fell in our lap, but we got the contract with the DIU, and I'll go through the commercials on that a bit later, but then we got additional contracts with other US primes such as Kratos, and now it's become this product that, you know, we're on the panel with the UK MOD. I'm going to London to meet them tonight, and everyone's interested in that vehicle, mostly because it's a good counter-hypersonics vehicle, because everyone wants to try and shoot it down, and it's also got a good payload for testing various technologies. So 9 kilos doesn't sound like much, but you can fit a lot of kit in there and test a lot of different things. Hypertwin X is what we've called our digital twin software as a service platform. So the data we get from our flights will be fed into Hypertwin X, which is basically a multi-physics planning, concept planning, digital battle management planning software, which we're working on. But apart from battle management systems, it really is a way for us to recycle the learnings from each of our flights to improve our product. And we think it's not just important to us from a development tool, but it will be very valuable in the marketplace as well. So we have put a very strong emphasis on the fact that we are primarily a hardware company, but the software we produce and the data we produce is going to be incredibly important for us to develop even more vehicles into the future. Visor, which is what we're just starting to work on now, which is our second generation vehicle. It's about 2.5 times the size of a Dart. It's about 8.8 meters long. It has landing gear. It still needs to be boosted into orbit, boosted into the atmosphere. And it has a 100 kilo payload, and it has a range of 2,500 and gets up to Mach 10. Now that's was originally designed to be like an ISR and a graduation point. So Dart is 3.7 meters long. The visor is 8.8, and we'll get to Delta Velos. Delta Velos is about 13 meters long. Both these two vehicles will have landing gear, and will be quite different applications. But the interest in Visor at the moment is purely military. They want to use it as an ISR. It could be, a hypersonic ISR. Think of like the Blackbird, but without a person on board and flying 3 times as fast. That's the vision for that. But the final vision for our company, and what gets us out of bed every morning, apart from all this other cool stuff, is Delta Velos. Now, Delta Velos will be a stage in low Earth orbit launching system. It'll have a third stage kick stage on the back of it. You can see there. And it will be able to fly just on the edge of space, come back and land. This is the product that we're really working towards commercializing and getting to testing in the next 4 years. And it's something that, whilst we are scaling and manufacturing the darts, which is great it's great for the business, and it's good to sell things if you're in business, obviously. That's the whole idea, that we get out of bed every morning to sell stuff. But it's also, this is our vision. This is our really big, exciting goal that we really are working towards, and what Michael started the business for. So it has a 150 to 300 kilo payload, again 2,500 range, and it gets up to Mach 12. And both these two vehicles will be in CMCs. There might be some in Canal structure, but primarily in CMCs, because to get past Mach 7 and to fly for up to 25 minutes, you need to have a CMC structure. And again, so this is a bigger picture of the Dart. Again, the first mission is later this year, so we're expecting that between October and December. It's a hypersonic testbed at this stage, counter-hypersonic target. There is interest in potentially turning this into a weapon. We haven't started to really look into that, but it is something that is of interest. But if we did do that, it would be further down the track when we have more understanding of how we can construct it differently, and we'd probably work with a partner. Our goal is to make these vehicles very reliable and as affordable as possible. Again, this is Visor, fully autonomous, aerodynamic guidance and control, and it's got 100 kilo payload. Access data as a service and payload recovery, multi-material construction. So that's the vehicle that we're currently in our systems requirements stage of planning. And then again, Delta Velos, which is what's our most exciting vehicle in my opinion, and this is the access to LEO, and it's something that for Michael, who's our founder, is a really, really important project, and we're really looking forward to being able to spend more time and more money on this project over the next 2 years. And Hypertwin-X, again, this is our mission concept evaluation, counter hypersonics and virtual testbed evaluation, multi-physics planning software using the data from our flights. Now, what's really important to our business in the next 2 to 3 years, which is something that which is pretty much exclusively of interest to the Dart vehicle, our first vehicle, is the fact that we 3D print virtually the whole airframe. The whole airframe's 3D printed. all of the avionics, all of the components are off-the-shelf components, so it's commercial off-the-shelf. There's no ITAR. We've designed it in such a way that there's absolutely no ITAR. So that means that there's not going to be any export issues in exporting it to different countries. Well, not every country, but most countries, let's just say. Yeah. Friendly countries. Okay, additive manufacturing enables us to not just build these vehicles quickly and to scale quickly, but we can do 3D printing anywhere. You got 3D printers in Poland, we can build these in Poland. You got 3D printers in Austria, we can build them in Austria. You know, we can build them anywhere and we can assemble them anywhere. It's not as simple as I'm sure most of you know, as they're spitting it out of a printer and bolting it together, but it is also, it's not as difficult as machining either. It's something that you can second a team to a location, maybe a team of 7 or 8 people, and you can build these vehicles. So in the future, using different applications for the DART vehicle, this is really important commercially. A lot of countries want this capability, but they also want this capability in their own country so that they can make them themselves for obvious reasons. So it's a good piece of tech for that reason. CMC materials, the leading edges, combustor components and control surfaces, we can't get away from that. We need to have CMCs. So CMCs, I don't think there's anyone in Australia at this stage who actually makes the CMCs that we need. Everything we're getting is currently coming from Europe. It's a very fast-changing capability, but we're obviously keeping a very close eye on it. And the thermal protection. So the biggest challenge we have in these vehicles, as I'm sure you know, is thermal protection because they get very, very hot. So we've used some very, you probably look at the tech and you think you wouldn't think that tech like that would work. It's quite simple technology, but we're applying different pieces of technology from different industries to reduce the costs and make these vehicles more accessible. We're using the Elon Musk model, basically, you know, in the past, in the 70s when NASA was building rockets, they'd spend $10,000 on a hammer or $5,000 on a spanner, and it would be a spanner that's specifically built for NASA. But then they realized if they got something from the motor industry, it would be just as effective. So we're trying to use as many different technologies from different industries to keep the costs down and prove that you can build these vehicles for a fraction of the cost of what the primes can build them, basically. So we can distribute our manufacturing all over the world. We are looking at doing that. We're currently manufacturing everything in Australia. It's about 85% sourced from Australia, but then there's 15% mostly from Europe. It's almost entirely from Europe. But we do see this as being a technology that we can easily scale into other regions. Now, our first program with the DIU for the DART is going to be in the last quarter of this year. The first flight, it will be the first flight demonstration. It will be completely done from the US. We'll have a small team over there, and it's a part of what's called the HiCAT program with the Defence Innovation Unit. Our boosting rocket will be our Kiwi friends Rocket Lab. So we're very happy to be working with Rocket Lab. And it's a program that we've been able to invoice DIU, get payments, build a vehicle, get mentoring for the team throughout the cycle of milestone development. And now we're going to our first launch, and we've got further launches of the DIU coming up as well. We're also on the UK HTCDF Hypersonics panel. So we applied to be on that panel last year. We were immediately accepted. And the areas of collaboration of consortium bidding that we're looking at the moment is local UK manufacturing, additive manufacturing, CMCs, helping the supply chain in the UK potentially help build our vehicles over there, novel high temperature materials, and UK sovereign booster manufacturers. So they've been very good to us. We're working very closely with them, hoping to get a launch contract very soon. Hypersonics test and evaluation of sovereign technology. We see the DART over the next 3 to 4 years to be a testbed technology. There's a lot of space tech, a lot of defense tech that really needs to get hypersonic heritage. They need to have experience in flying at hypersonic speeds. How does their technology work at hypersonic speeds? How does it work at 50 degrees or 60 degrees? How long can it work in that environment? That's why this particular vehicle, the Dart, is so important, and there's so much interest in it, because there's a lot of ways that we can test other complementary technologies with that piece of kit. And just so you know, that vehicle at the moment would cost, we're selling these vehicles for about 5% of what a prime would be selling these vehicles for. It's quite a significant price drop, and it's something that we're very, very proud of. But it is a turnkey service. Hypersonic provides internal and external payload options, so we can do internal, external payload options. And it's a piece of technology that we're going to be hopefully launching from Australia, from New Zealand, from US, and hopefully from Andoya in Europe, or possibly the Hebrides in the UK. So we've got really grand plans to do as much testing with this vehicle as possible, and provide insights to other complementary technologies as well. And I think that's the last slide for me, but I'd like to just go for a few other things about our business and about the space industry and capital raising and what we what's been the successful aspects of what we've done. Our business was, I think in some markets it was like a lot of space industries. It's hard to understand for a lot of investors. It was certainly hard to understand for Australian investors. So what we needed to do is to really build a commercial validated plan that can demonstrate that this technology can be both defense-based as well as dual use. If it's just defense, it's good, but if it's dual use and defense, you've got much more chance of securing investment, in my view, because you've got defense can be famine and feast. You can make a lot of money in defense, and then for 3 or 4 years have no revenue. So we're really focusing on the dual use aspects of this technology. So when we talk about payload testing and we talk about different technologies benefiting from what we're doing, we're looking at it from a dual use perspective, because the companies that are looking to use our payload are looking at it from dual use perspective. So we're really pushing that hard. We're also pushing the defense aspects hard because we need to make money, but we also know that unless we have that dual use aspect, it's going to be something that potentially is more difficult to sustain when there's less requirement for defense. But that's pretty much our story. We're very proud of what we've done and really, really appreciate the invitation today to be here. So thank you. And looking forward to hearing some of the other presentations as well.
Thank you, Matt, for your presentation. I think working on products that can fly 5 up to 10 times faster than the speed of sound it's really incredible. And as you are our keynote speaker, we have 15 minutes of Q&A session for you. So if anyone in the audience would like to ask some questions to Matt, please, we can pass you the microphone. We have already one person. And in the meantime, one question from my side. Do you plan to become a public listed company, as we are in the heart of the capital market on Poland?
We plan to give our investors a liquidity event, and if it's through a public listing, we would definitely consider that. It's obviously one of the ways we could provide our investors with a liquidity event. Experience would tell me in a business like ours it might end up being a trade sale, but it's definitely something that we're building the business in such a way that it would be attractive for an IPO if that was the right thing to do in the future. Yeah.
Okay, great to hear. The first question from our investor.
Hello, my name is Peter Manzelov. Thank you for the interesting presentation. Consider my question as a type of devil's advocate. What is wrong with the Australian capital market? The listed companies are worth around $2 trillion. the Polish stock market, Polish capital market is less than 30% of that. You have in Australia very well developed VCs, PEs. So what brings you here in Poland? If you can elaborate on that. Thank you.
Well, thank you for your question, Peter. I don't want to be too disparaging of my compatriots, Australians, but Australians, we do have quite a lot of Australian investment in our company. In fact, the Australian government as well. But we're in Poland because we've got quite a large, high-profile investor in our business who Matusz Boder, who came in with RKK VC, and we're building a very close relationship with Matusz and his investors, but also we are looking for a footprint in Europe, and Poland does seem to be like a very natural fit for us because it's the level of capability in terms of small to medium-sized businesses, engineering businesses that could help us, particularly 3D printing, they're all here. So yeah, and the central location of Poland and the security, it has the right profile for us, yeah.
Any more questions from the audience? Please.
Okay. Hi, my name is JJ Kowalewski, and I have a question on your business side related to digital twins. Because you said you use this kind of software a lot and you produce this kind of software. From my perspective, it would be good to know how exactly you use that, how it gives you advantage, and also what's the split between the business, let's say, composition. Because you say you also try to sell the digital twin software, and we have some companies in Poland that are also developing digital twin software, so this will be very good to hear.
Yeah, for us, the digital twin software was originally, we were going to use it to help, it's part of our design cycle and just trying to improve the product. But there are partners or potential partners out there who have shown interest in how could we commercialize this whilst also not giving away our IP, basically. We don't want to be, we want to help, we want to be able to turn it into a product that we can sell without selling all of our IP in the process. But we're using, I can't talk about the specific software, but we are using software that has been in long use in hypersonic testing, and we've been able to access full IP proprietary of that software, and we're also developing that with the data that we're going to get from our flights, and putting it in a format that can be applied to a battle management system, or it can improve our current multi-physics simulation. Because as you know, with hypersonic vehicles, it's all about keeping the temperature down. So the number one factor we want to get from our software is how do we keep the temperature down and how can we fly for longer. And I know it doesn't answer your question about the software itself, but the software we're using is very, very specialized. We've acquired it and we're building onto that software, yeah.
Any more questions from the audience?
Yes, hello, my name is Michael Nastula. I have the following question. In your business, you cooperate naturally with defense industry. I understand, basically all over the world. Is military conflicts, like, for instance, war in the Ukraine, something that you monitor to see the changes in the battlefield, or it's you leave it, let's say, for outside partners? My question is it something you look into to decide on the direction of the development of your company or not?
Yes.
Thank you.
Well, I mean, it doesn't. Thank you for your question, Michael. It doesn't deviate us from our original mission, which is to float at low Earth orbit using hydrogen-powered scramjets. But it does influence the development of, say, the DART vehicle and what we can do with DART and what are the other applications. So yes, we do. We definitely monitor what's going on in Ukraine. We monitor what other non-friendly players are using and the way they're developing. and we try to develop that, products that can outmaneuver or out-achieve what those products are achieving, because it is another area of revenue for our business, and it's also another way that our business can really work to. We want our vehicles to be used for good. We want them to be used for good and to support freedom and all of those sorts of things. I don't want to sound too cliche, but so yes, we do. Like if there's an application for DART that can be used in that battlefield, and it's proven and it's battlefield tested and it's got an application, we'll certainly look into it. And if we can, we'll fast track towards it. Yeah.
Last two questions, please.
I have a second question. If you can elaborate somewhat on the non-military civil applications, the most obvious one of your technology. Thank you.
Sure. It's definitely it's test bed. It's test bedding the technology, and it's also the access to space. So we're developing Delta Velos as an alternate way to deploy satellites, and that's the major application that we're using it for. But we're also, the way that we can validate technologies at hypersonic speeds, it's not just for military. The technologies we're validating are not just military technologies. They're technologies that apply to future hypersonic civilian applications. So, for example, you've got companies like Hermes in the States, and we don't have a contract with Hermes, but Hermes are building vehicles to fly at hypersonic speeds, or at least at supersonic speeds. Their vehicles are very expensive, and for them to test their vehicles costs significantly more than for us to test a DART. So we could, anything that they need to validate for their testing to be able to get into the air and not waste $45 million in the process, we can help them with that. So, and then we've got the digital twinning from that, which we can also help them as well, so that they don't need to, drop one of their vehicles from a plane to see if it works. So we can help them improve their testing, because there's a lot of companies in the hypersonic space that are trying to shake things up and trying to improve the landscape. We can help them do that, and we can do that in a much more affordable way.
Hello, my name is Przemysław Droszcz. First of all, great presentation. Thank you for that. I have a question, technical one. You mentioned you are planning to reach space, low Earth orbit, basically, which obviously you cannot reach only on scramjet technology.
Correct.
Yeah. So my question is, do you plan to develop your own second stage, and are you working? All right. So that's a simple question. So
Yeah.
and simple answer. So as I understand, if I understand correctly, you're planning basically to buy this second stage from third party.
Yeah. Well, look, the rocket and booster market is becoming highly contested. There's a lot of players out there, and there's so many parties that we can work with. We're already working with Rocket Labs. We're working with Kratos in the States. So we're working with HASTE with Rocket Lab, Zeus with Kratos. There's a lot of rocket companies and Crossbow that's coming out of the States now. You can basically go there and say, I want this, I want that, I want that. They'll build you a rocket. It'll fit whatever the diameter is. Bang, it's on the back of the rocket. So we see the booster market as being, it's not a problem that we want to solve. It's a problem that, it's like we're the party and they're the Uber to the party. That's the way we see it, yeah.
Ladies and gentlemen, as we have to move on with our SpaceDay agenda to the next points of our program, I want to thank you, Matt, one more time for your presentation here today, for your answers. And please be invited to talk with our space representatives in the background. And we are moving to the first discussion panel. Thank you, Matt, for being with us today.
Thank you very much.
Thank you.